In this video, we're going to cover section 6.5, which is going to be on the law of sines. And I want to discuss the more general purpose for this section in the next one. So the fact that we've been using that sine of some angle is equivalent to the opposite side over the hypotenuse. Cosine of some angle is the adjacent side of the triangle over the hypotenuse, and so on. Well, that only applies to right triangles. Okay. So when we have a triangle that's not a right triangle, it's going to mean it's going to have some obtuse angle, meaning some angle between or bigger than 90 degrees, but less than 180. Okay. And yeah, we'll call these oblique triangles. And so before we get our rule, we need to see where it comes from. And so what I'm going to try to do here is make a 90-degree angle going from C to the side that goes from A to B. Okay, so the hope is that this right here looks like a 90-degree angle. There we go. And let's go ahead and label this side as H. And I'm going to have us do the same thing with the other triangle. I'm going to find a spot where we can make a 90-degree angle. And that's going to be from this point A down to the horizontal. And we're going to call the height of this one H prime. There we go. And let's go back to that first triangle here, and we're going to write down a few equations. So let's look at the angle A. So sine of A should be equal to the opposite side over the hypotenuse. And you can see the opposite side here with this little right triangle we have here is H. And then the hypotenuse should be the side opposite of the 90-degree angle. And our 90-degree angle is right here. Okay. So that's going to be side B. Okay. So I have sine of A is equal to H over little b. I want us to now focus in on angle B. Okay. So we can write something involving sine of B here. And so if we look at the side opposite of that, it's H. And the hypotenuse is, again, what's opposite of the 90-degree angle. So that's side A here. There we go. So we have these two equations. We can solve these both for H if we'd like to. If we did that here, we're going to get H is equal to B sine A. And for this bottom one here, we're going to get H equals A sine of big B. Okay. And all I did on both of these is this top one here, I multiplied both sides of the equation by B. Okay. And for this one, I multiplied both sides of the equation by A in order to isolate H. Okay. Well, now that we know that these are both equal to H, we can actually do something else. Okay. We can take both of those and set them equal, since we know they're both equal to H. And so that gives us B, so little b, sine of big A is equal to little a sine of big B. And we can do a couple things here. One is we could divide both sides by A, and we could divide both sides by B. And so if we divide both sides by A and B, we're going to end up with a sine of A, and that's a big A, divided by little a, and sine of big B divided by little b. So this is actually one part of the law of sines. There's an extra piece we're going to add to this. You might be able to imagine what it is. Okay. But if you're not sure, we're going to find out. We're going to start working on this second triangle now. And in the end, we'll write some very similar to what we're seeing here. All right. So I'm actually going to have us this time begin with a trig identity. So this is called the difference identity, and we will actually learn this identity later this quarter. Okay. But let me start off by just writing sine of 180 minus big C. Okay. And you may notice so far, everything that is an angle we have labeled with a capital letter and the sides with a lowercase. Okay. So I'm going to use that convention as we work through this. But do keep in mind, not every textbook is going to use this convention, but it is a pretty common one. And if we keep going here, this is the identity. So this part we'll just have to know we're going to learn this later. But this is equal to sine of 180 cosine of big C minus cosine of 180 and then sine of C. And again, this is called, I'm going to actually write it here just in case any of you want to look into it. What we applied here is it's called a difference identity. And when you look it up, you might want to look up sum and difference identities probably to make it pop up. But okay, here we go. And then from here, we know that sine of 180 is 0. So this is just going to go away. Okay. But it wouldn't be a bad idea if I wrote this step in here. 0 times cosine of C. And then cosine of 180, that's actually minus 1. And so if we simplify what we have here, we just have a positive sine of C. All right. And so is what we're going to look at as we go here is we're going to look at sine of C and we're going to look at sine of B. Okay. So let's go ahead and write those down. Let's start off with sine of. Actually, before I do that, I want to just star some of this. That way we don't mix up kind of the steps here. And so our next step here is going to be to look at two things. Again, sine of big C, and we're going to look at sine of big B. And so if we note where C is, it is right here. We've shown that sine of 180 minus C is equal to sine of C. Okay. So is what I'm trying to get at is in this little spot right here. Let me see if I can actually write this in with a smaller font. I'm going to zoom us way in here. And so I'm going to try to write in here 180 minus C. Let me see if I can just write that a little bit more clearly. There we go. So that'd be this angle right here. So rather than looking at this triangle and trying to find sine of big C, I can instead look at 180 minus C, and that'll work just as well. And this is important because the triangle that has the angle C in it is not a right triangle, but the one that has 180 minus C is. So if we're trying to find sine of 180 minus C, we would like to take the opposite side and divide it by the hypotenuse. So the opposite side is h prime, and the hypotenuse is b. So we're going to have h prime over b here. Oh, and let me switch back to a bigger marker. Here we go. H prime over b. Okay. And then let's go ahead and find sine of big B. Okay. And so now we want to look at the big triangle here. What do I mean by the big triangle? I mean from here to here to here. And I know that's a little sloppy, but this is what I'm looking at here. Okay. So sine of B, again, should be opposite over hypotenuse. So that's H prime over C. Let's go and write that down here. And you can probably guess, we're going to do the same thing that we did last time from here. We're going to solve these both for H prime because, right, last time we solved these for H. Okay. So I need to multiply both sides of this equation by B, and that'll give me H prime equals little b sine of big C. This second equation, I want to multiply both sides by little c, and so I get H prime is equal to little c sine of big B. And then I'm going to do the same thing that we did for the next step, which is I'm going to set these both equal. Since they're both equal to H prime, they're both equal to each other. And so is what I mean is I'm going to write in here little b sine of big C is equal to little c sine of big B. There we go. And I can solve for this in a similar fashion. In other words, I can have sine of some angle over some side length. And in order to do that, I want to divide both sides by C and B. And so that'll give us sine of big C is equal to sine of big B. And so the one on the left here is going to be over little c, and the one on the right here is going to be over little b. And so now we have everything we need to officially write down our law of sines. So if we were to combine both this piece of information here and this piece here, we end up with what we call the law of sines, which is we end up with sine of big A over little a is equal to sine of big B over little b, which is equal to sine of big C over little c. Okay. And so you rarely will use all, I don't know what to call these exactly, all three of these pieces at the same time. Usually you'll just combine two of them. So you might use these two are equal, or maybe these two are equal, or these two. Okay. Yeah, you rarely will write down all of these. All right, so let's actually try out a problem. And it says to solve the triangle round angles to the nearest degree and the lengths of sides to the nearest tenth. And so when you see the phrase solve the triangle, that just simply means find the remaining sides and angles for the triangle. And so looking at this, let's see. So there is something that I'm looking for here. I want to see a matching angle and side. Okay. And is what I mean by that is if we were to label these using the same labeling that we did in the diagram on the previous page, we'd probably call this angle right here that's 33, we'd probably call that big A. We'd probably call this little a. This would be big C here. And am I missing anything? No. Okay. So the point is I would like to have a side and angle that have the same letter. Okay. And so we do have that here. And you'll need this, otherwise you won't be able to solve for the intended variable. Okay. Now we do have something else here. So we also have this angle, but we're missing the side. So if we were to use the formula up there, we'd be thinking about sine of big A over little a is equal to sine of big C over little c. And we can write that down with our given numbers here if we'd like to. But I'm going to write things in a slightly different order. So I maybe want to mention one more thing about this. Okay. So this is one way that you can write your law of sines. Okay. In fact, there is another way. So you could use little a over sine of big A is equal to little b over sine of big B is equal to little c over sine of big C. Okay. All right, and so this makes sense. Let me explain what I mean. Okay, so let's say you had two fractions that were equal. For instance, 4 halves is equal to, let's see, let's go with 6 thirds. Okay, these are both equal to 2. And if you flip them over, well, they'll both just be equal to a half. Okay. But the point is if you have two things that are equal, as long as nothing's zero, then they'll also be equal if you flip them over. And the reason I'm saying that is down here, I want it actually to be easier to solve for little c. So I'm going to actually write little c on top. Okay, I'm going to have this divided by sine of big C. And big C, we know what it is, right? It's 128 degrees. And then this is equal to little a, which is 16, over sine of big A. And big A is 33. So is what I was trying to get at is this equation here is going to be easier to solve with the c in the numerator, because if it were in the denominator instead, I'd have to do an extra step to get it out of the denominator before I could solve for it. Right now, all we really have left to do here for the step that we're working on is actually isolate this equation in order to solve for c. And all we'd have to do is just multiply each side by sine of 128. So we're going to get c equals 16 sine of 128, and then that's divided by sine of 33. Now, in the directions up here, after I write in my degree symbol, it says to round angles to the nearest degree and lengths to the nearest tenth. So is what we're going to want to do here is plug this into the calculator and round it to the nearest tenth, since C is a side length. Here we go. So I do want to make sure I'm in degrees since the angles were measured in degrees. So I'm going to come down here and hit enter. And then we can quit out of here. And so now I want to type in 16 sine of 128 divided by sine of 33. And hit enter. And so if I round that to the first decimal place, I get 23.1. So let's go ahead and record that here. Okay. Now, in the online homework, when they ask you to find multiple things here, I believe that they are going to expect that you use this new rounded value to find the next thing. Okay. I want to show you what you would do if instead we wanted to make sure we didn't lose any accuracy. Okay. Because of course it's easy to now just use C equals 23.1. But let's say we didn't want to lose that accuracy. Okay. So here's what I would do. If this were a value I thought I was going to need again. And I don't know that I need it again yet or not, so I might be wasting a little bit of time here, but let me show you what I would do. Okay. So I come down here and I'd hit this STO button. And now that STO stands for store. And so I can store this number in the calculator and I won't lose any of the accuracy that I currently have. Okay. So I'm going to store this as C. I'm going to hit alpha and then I'm going to hit program here because program has the C above it. Okay. And just hit enter. Okay. And so now anytime I use C, it's going to be equal to that stored value. And again, I won't lose that accuracy that I might be concerned about. Okay. So let's come back down here. And so all we found is C. We still need to find B, big B and little b. Okay. And I'm just realizing this now, but we can actually find ourselves little b without really doing much work. We already know these two angles. So if we want to know big B here, well, I know that all three of those angles should add up to 180. So big B should just be equal to 180 minus 128 and minus the 33. Okay. All right. And so let's go ahead and see what that's equal to. Okay. So we have 180 minus 128 minus 33. And let me pull that over. We get 19. So that angle B is equal to exactly, we're not rounding here on this one. It's equal to 19 degrees. Okay. There we go. The only thing we're left with now is little b. Let's go ahead and find that. Okay. So we could use law of sines again. And again, I'm solving for a length. So it would be nice if little b were in the numerator. So I'm going to write it like this. I'm going to say little b over sine of big B, which is 19. And I have a choice here. Okay. I can now do little a over sine of big A or little c over sine of big C. Okay. Well, if I use little c, then I'll be forced to use this stored value on the calculator, okay, which is not a big deal. Okay. I'm going to have us do that later. But we already have big A and little a, and they're both nice numbers. So why don't we just use those? So I'm going to write in little a, which is 16, divided by sine of 33. And then we want to solve this for little b. So we could multiply both sides by sine of 19. So I have 16 sine of 19 degrees divided by sine of 33 degrees. And so we can type this in here, 16 sine of 19 divided by sine of, and I think it was 33, yeah. And so we're getting here about 9.56. Okay. And it did say again to round side lengths to the nearest tenth. And so if we round this to the nearest tenth, that's going to be 9.6. Okay. There we go. So now we have officially solved the triangle. All right, let's give another one of these a try. This one says to find the angle B to the nearest degree. And is what I want you all to notice about that angle B is it's a little bigger than 90 degrees. So keep that in mind. And that fact is going to pop up here in a little bit. Other than that fact, though, let's note that we do have a matching angle inside. Okay. Additionally, I do want to find this angle B, and I have the side opposite of it. So when I go to set up my equation here, all right, I would actually this time like to have the angle on top so that it's easier to solve for. So I'm going to put sine of big B over its corresponding side length, which is 31.8 feet. And then I have this side and angle that match here. So I'm going to write in sine of 38 divided by 20. And if I want to solve this for B, I need to multiply both sides by 31.8 first. So if we do that, we get 31.8 sine of 38. And then finally divided by 20. Okay. And to finish solving this for B, we want to take sine inverse of each side. There we go. All right, now I'm going to have us plug this into the calculator and we'll see what we get. So let's scoot this over. There we go. So I want second and then the sine button to get inverse sine, and then 31.8 sine of 38 divided by 20. Let's just make sure that that's typed in right now. There we go. Yeah. And so I'm going to go ahead and hit enter here. And so I'm getting this about 78.2. Okay, so there's a reason that we needed to think about the fact that angle B was bigger than 90 degrees. Okay? And it's because when we actually go and solve for B here, we get something that's less than 90 degrees. Okay? So this right here is not actually the angle B that we're looking for. There's another angle. Okay? And so is what's going on here is something interesting that has to do with our inverse functions. So you might remember, I'm going to make a little sketch here, but you might remember that sine inverse can only give you angles between minus pi over 2 and pi over 2. And if you were to convert that to be in degrees, okay, that would mean that sine inverse can only give us angles in between minus 90 degrees and 90 degrees. Okay. So B is bigger than 90. So let's make a sketch of what this B looks like that we solved for. This B, it still has its terminal side here, or sorry, not terminal, it still has its initial side here. But yeah, its terminal side is somewhere up here. Okay. And so you might remember that when we're trying to find sine inverse, if we're trying to find sine inverse of something, is what we're really looking for is what angle will give us a y value that's equal to this. Okay. And so that y value is this one right here that we have sketched in. Okay. Well, that's not the only y value on the unit circle where this had or where we have this y value. If you go straight across, you'll end up right here. Okay. And I could sketch that angle in. Okay. So that blue angle is actually the angle we want to find. So maybe we could say here that this, instead of calling it B, let's maybe call it maybe B star. And just kind of indicating this isn't the one we were looking for. Okay. So in our sketch, it's this. Okay. I also want us to note that it is 180 degrees to get to here. Okay. And I also want you to see something else. Okay. That this angle B that goes from here to here is actually also the angle that is right here. Okay. All right. And so what I'm trying to tell you is that if we do 180 minus B star, we'll actually end up with the angle we want, which is this one. Okay. And I'm going to call that angle, I'm going to call it B. I'm going to write this other B star, though, in a different color. I feel like it's standing out a little too much. There we go. All right, so is what this means is that the B we're looking for is actually 180 minus B star. Okay. So I'm going to go back to my calculator, and I'm just going to do 180 minus our previous answer. Okay. Now, let me see what this question says to round to, but this is the angle we are looking for. I think it says to the nearest degree. So if we round this to the nearest degree, this will round up to 102 degrees. So let's go record that. Now, this also does, or there's something else that we can get from this. So it actually ends up that anytime you are looking for an obtuse angle, like this one, okay, you're gonna wind up needing to do 180 minus sine inverse, in order to get what you're looking for. Okay. All right. Well, we're gonna do a few more here. Okay. So I think that this wouldn't be a bad time to go ahead and pause the video and see if you can do this question. All right. So we know we're going to use law of sines here again, but for one, let's note why we need to use it. And that is, this is not a right triangle. All right. Now let's go ahead and read the question. So it says a tower leans at an angle of about 84.7 degrees. The figure shows that 155 feet from the base of the tower, the angle of elevation to the top is 53 degrees. Find the distance to the nearest foot from the base to the top of the tower. So we're looking for little b over here. And another thing that we would hope for, as I've mentioned in the past, is that we would have a side length and a corresponding angle. And at first glance, it looks like we are missing the angle C, but they've given us actually enough information to figure out what C is equal to, right? So this is a triangle, so all three angles should add up to 180. So to find big C here, we should just be able to do, well, 180 minus 84.7 and then minus 53. All right, and let's scoot this over and we'll plug it into the calculator. All right, so 180 minus 84.7 and then minus 53. Okay. So we're getting here a 42.3. Go. So we have C now, big C. So one of our sides is going to be, let's say, little c over sine of big C is equal to little b over sine of big B. So let's go ahead and write that. So I'm going to start off with the b because that's what we're solving for. So I purposely am putting the side lengths on the top here. So I have little b is equal to sine of big B, which is 53 degrees even. And then on the other side, I have my side length of little c, which is 155. And then I want to divide that by sine of big C. Okay, and big C we found up above is 42.3. And so in order to solve for little b here, all we need to do is multiply both sides by sine of 53. All right, let's get that plugged in and see what we get. Here we go. So we have 155 sine of 53 divided by sine of 42.3. And let's see what this rounds to. So we wanted to round the side length or this distance to the nearest foot. So the nearest whole number here. So if we round that to the nearest whole number, it looks like we're going to get 184. So about 184 feet. There we go. All right. So we have really one more topic here in the law of sines, and this is going to be about something that we call the ambiguous case. So it ends up that sometimes when we're given, say, one angle and two sides like this, we can actually still complete the triangle, even though this is all we know about it. But sometimes there's multiple triangles that might be able to satisfy these conditions. And then sometimes there's no triangles that will satisfy these conditions. And so that's what we're going to go through and look at is what does this look like in each case? So let's go ahead and we'll just start off by noting again, well, we have an angle and its corresponding side. So that's good. We'll be able to use law of sines. And then we have little b here. Okay, so this means the only thing we can find right now is big B. Okay. So if we start setting this up here, we're going to have sine of big B divided by little b is equal to sine of big A, which is 38, divided by little a, which is 40. And if we solve that for b, or I'm going to solve it for sine of b first. I'm going to get this 52 sine of 38 and then divided by 40. Okay. All right, so when I do go to solve for b here, I'm going to have to use sine inverse. And sine inverse can only give us angles between minus 90 and 90. So in other words, if this angle B is actually an obtuse angle, we're going to have to do 180 minus sine inverse. Okay? But also, maybe big B is an acute angle. Okay? And is what we're going to see is we're going to end up with two possibilities here. Okay? So I'm going to break this up into two sections. And in one, I'm going to just leave this as, I'm going to write B1. Okay, but I'm solving for B here. So I'm going to take sine inverse of each side. And if I do that, I get B1 equals sine inverse of 52 sine of 38. divided by 40. Okay. And again, this is going to give me the possibility for the acute angle versus on the other side, we're going to write down what it would look like if we got the obtuse angle. And remember, to get the obtuse angle, you're going to do 180 minus sine inverse of, and then for us here, it's going to be 52 sine of 38 divided by 40. There we go. All right, so let's work with the triangle on the left here first, okay? And so if we pull up our calculator here, I'm going to have second and then sine for sine inverse, 52 sine of 38. And then I want to divide that by 40. And then I'm going to close that off and hit enter. So I'm getting here about 53.2 if I round to the first decimal place. Let me see what the instructions said for rounding here. Actually, it doesn't say any. So let's just round everything to one decimal place here. So B1 then is going to be, 53.2. So here we go. Okay. Next, we're missing little c and big C. Okay. We don't have either one of those. Okay. But do note that we do have B here now. Okay. So if we were to do 180 minus A minus B, we will get big C. So let's try and do that here. So big C should be equal to, and I'm going to call this C1, 180 minus B1 and minus A, which is 38. Before I do that in my calculator, though, I am going to store this time just in case I want to reuse B at some point. So I could hit STO and then alpha and then apps, because you can see above apps there's this B, just in case I want to use this at some point. But either way, we wanted to do 180 minus B1, which is really what I've stored on my calculator is B, and then minus A, and let me refresh my memory, A was 38. So now we're getting about 88.8. Okay. And I'm going to store this as C. I'm going to hit STO alpha C, because I am going to need this here in a minute. Okay. All right, so 88.8. Let's write down in the degree symbol on these so that we remember that these were the angles. And all we're missing now is side little c. So I can write in here little c. And you know what? I'll write it in with a different color. So little c, and let's call it little c1, divided by sine of big C1. Now, again, I think in your homework, they're going to want you to use this 88.8 to do the next step. But just as good practice, you generally don't want to do that. You want to keep the accuracy you had before. So I'm going to use my stored value for C1 here. And then this is all equal to, and if we arrow up, we could use little a, which is 40 on the top here, divided by sine of big A, which is 38. So sine of 38. And again, we're trying to solve for little c1. So I'm going to multiply both sides by sine of big C1. Okay, and then let me show you how I would do this on the calculator. Again, C1 is stored as C in my calculator right now. So I have 40 sine, and then I'm going to hit alpha C here. And then I can divide that by sine of 38. And I've lost no accuracy. Okay. And then finally, if I round this to 1 decimal place, I would actually have to round this up. So it would round up to 65.0. And this was the only one that we found that was a side length, so I'm not going to write the degree symbol for that one. Okay. So this is the first option. Okay. But again, B could have been an obtuse angle rather than an acute one. Okay. So is what I'm going to do here is I did store that B value in my calculator, the previous one. So I could type in here 180 minus alpha B. And so here's my obtuse angle, 126.8. Let's go record that. And that is an angle. Okay. Now we need to find the angle C2. And so to find the angle C2, it should just be 180 minus the other two angles. So we have B2, and then we have A, which was 38. Okay. So in my calculator here, I'm going to do 180 minus. Now my previous answer is B2, and then minus 38, which is A. Let me just double check that. There we go. All right, so now this is going to be the angle C. I'm going to label it as C2 over there, but let me hit store alpha C because I'm going to use this number again. Okay. But it's about 15.2. Okay, so I want to point something out here. When we're trying to decide whether there's one triangle or two, this will be the step where you will find out whether there is one or two. If I had subtracted these and got a negative number for C2, that would be the indicator that we're not going to be able to find a triangle that has these conditions. Okay. But this angle came out to something positive. So we will be able to finish this, and we're going to find little C2 now. And remember, big C2 is stored on the calculator. Then this is equal to 40 over sine of 38. And if I solve for C2, this is going to look a lot like last time. C2 is going to be equal to 40 sine of big C2 divided by sine of 38. All right, and so let's get that typed in. Okay. So we have 40 sine of alpha C, because that's what I have, again, stored for C2, and then divided by sine of 38. And so we're getting, if we round this to the nearest tenth or the first decimal place, this will actually round up to 17.0. There we go. All right, so these are our two possibilities here. This is truly ambiguous. We do not know which of the two triangles we're working with. Okay. All right, so let's go ahead and scoot down and look at another one. Okay. So this time, again, it is going to be, or at least appear to be at first, ambiguous, but we'll see whether or not it truly is ambiguous. So I'm going to have us start off in really the exact same way. We're going to try to find that angle big B. So I'm going to write on top here sine of big B is equal to sine of big A, which I'm going to write in as 112. And I want to divide each one of these by their corresponding sides. So the side opposite of the angle B is side B, which is 24. And then the side opposite of the angle A is side A, which is 45. There we go. And if we go ahead and we solve this for B, we're going to have some, well, I'm going to solve it for sine of B actually first. I'm going to have 24 sine of 112 over 45, just multiplied both sides of the equation by 24. And then finally, we'll take sine inverse of each side here to solve for B. Okay. But once again, we're not told whether or not this angle is going to be, the angle B is going to be obtuse or acute. Okay. So we may have two possibilities. We'll start off as if we do. And I think I'm also going to scoot this up and shrink it a little bit. Let me try and do that here real quick. There we go. So I just want to make as much room as possible here for us. So we'll do the exact same thing. Take sine inverse of each side here, and we have B1 equals sine inverse of 24 sine of 112 over 45. And if we want to, we could start writing B2 as well. But remember, for B2, we want to do 180 minus the sine inverse. So I'm going to write 180 minus sine inverse of 24 sine of 112 divided by 45. There we go. Okay. And so let's go ahead and plug both of these in. Why not? Okay. So sine inverse, there we go, of 24 times sine of 112 divided by 45. And then let's just make sure that we type that all in right. Okay, there we go. So this one here gives me about 29.6. And I'm going to store that one just in case I need it. I'm going to hit STO right here and then alpha apps for B. There we go. But B2, we said should be 180 minus this angle. And so that looks like it's going to be 150.4. There we go. We'll find big C just like last time too. Let's go ahead and do that. And this time I'm going to call it big C1 and big C2. And for both of those, remember, all three angles should add up to 180. So 180 minus B1 and minus A is how we're going to calculate C1. And we're going to calculate C2 the same way, except for instead of subtracting away B1, we have B2. But we still have that angle A, 112. Okay. Let's see here. So let's do 180 minus alpha B, which is B1, and then minus 112, which was A. And so that gives us a 38.4. So let's go record that. 38.4. There we go. And remember, these are both angles here. and B2 as well. So let's come back over here and remember, I need to recalculate B2. Remember, B2 is 180 minus really what B1 is. So I'm going to say 180 minus B. Okay. So this is what we were calling B2 here. So I'm going to do 180 minus B2 and then minus A, which is 112. Okay. And so let's see here. Oh. Let me go back. Let me go back. Yeah. I messed that up here a little bit. Okay, so 180 minus B, okay, or B1 gives us B2. Okay, so again, B2 is this 150.4. So I want to do 180 minus this number because this number that we're looking at here is B2. And then I want to also subtract away 112. Okay. So you can see this is giving us a negative 80 minus 82.4. So is what's going to wind up happening here is that this one here, we're only going to result in one triangle. So we didn't know this before we started. And the one up above, we ended up with two triangles. But this will be how you tell the difference is um, B2 is either going to be small enough that when you still add up all three of your angles and they're all positive, you get 180 versus over here in this one down here, this B2, it was too big because A was already 112. And if you add those together, they already add up to more than 180 and there's still a missing angle C. Okay. All right, well, let's go ahead and find little c here now. So we have little c1 divided by sine of c1 is equal to, and so let's go with little a, which is 45, and we'll divide that by sine of big A, which is 112. And if we solve this for little c1, and I'm pretty sure we already saved c1, but let's double check. Alpha c. And you can see that actually is different than that 38.4 we have there. So let's go ahead and actually recalculate it real quick. So we had 180 minus B minus 112. So I'm going to hit store now, and I'm going to store it as C. Okay, there we go. Now I can just type this in. I can say 45 sine of C divided by 112. And so when we do that here, we're getting about point. Let's see. Let me double check my work here. Yeah, we're getting a very small answer here. So yeah, we have 45 over sine of 112, and then little c1 over sine of c. Oh, obvious mistake. Down here, this should be sine of 112. There we go. Okay. So let's come back over here and we'll just retype this in, but with a sine of 112. There we go. That's a much more reasonable answer. So 30.1 is what we'll record here. There we go. Right, and then we just have one left here. So this time, let's see. We're in a very similar situation. We have one angle and two sides. Okay. So we can start setting up our law of sines. So I can say sine of big A divided by little a is equal to sine of big B over little b. Okay. And sine of big B, right, was 73. There we go. All right, so we want to start solving for A. And so I can multiply each side of this equation by 92. And technically, there is something kind of wrong here. Okay. And it's not really our work or anything like that. It has more sort of to do with the question itself. So if you were to actually take this number right here, 92 sine of 73 over 51, see what that looks like. And before I hit enter, I want you to think about this. What's the biggest value that sine could have? And well, the biggest it could be is 1. And the smallest it could be is -1. Sine only gives you numbers in between -1 and 1. Okay. And I'm pointing this out because over here we have sine of A equal to a number. So that number better be between -1 and 1. Okay. So if I hit enter here, you actually see we get something bigger than 1. So this is impossible. Okay. But let's say that you didn't notice that was impossible. Well, you could hit second, sine inverse, and you could plug in that number that we have there into it. And if I hit enter, you actually see we get an error, and it's a domain error. Okay. So is what the deal is, well, this is impossible. Okay. So is what this also means is there is no triangle in this case. So maybe I'll put 0 triangles. So this literally means no triangle has these exact 3 conditions. It's not possible. Okay. Let's just write in here though that no triangle. Let me scoot this down. All right, and so that actually wraps up 6.5 here on the law of sines.